last topic we want to look at in week 3 is functions. Now, functions is a big topic. It's really important in Math 103, but we don't really talk about it again in Math 99 except right here. So we're going to say that the quiz about functions will be due after test 1. That means it's going to be on test 2. Now, a function is a special relationship between x and y. In a function, each x value or each input has exactly one output or exactly one y value. So look at this equation here, for example. You should recognize that this is a linear equation. X to the power of 1, y to the power of 1. In fact, this is in slope-intercept form. We can see that if we put in x equals 1, y equals 5. That's the only value that y will be. There's only one output. Let's try another input. When x is 0, when we put in x equals 0, y equals 2. What if x is a negative number? Pause your video, find the output. -6 plus 2 is -4. That means that this is a function. Every input had exactly one output. Here's another equation. Let's try some input values, -1, 0, and 2. Pause your video, find the output for each of these. Are these the values you found for y? Again, when we input one value of x, we only found one value for y as an output. Both of these equations are examples of functions. Let's look at this example. If we input a value for x, let's say 9, and now remember, we can find the square root of both sides. Let me move that over a little bit. Do you remember when we find the square root, we need the positive and negative square root. Y could be the positive square root of 9, or y could be the negative square root of 9. Y could be positive 3 or negative 3. Think about that. 3 squared equals 9. -3 squared equals 9. What if we have an input of 49 for x? Again, when we find the square root of both sides, we see that y could equal the positive square root of 49 or the negative square root of 49. Y could be 7 or -7. Here's a little bit of a tricky one. What if our input is 3? We still need to find the positive and negative root. Y could be the positive square root of 3 or the negative square root of 3. This equation is not a function. The input, our x value, has more than one output, more than one y value. One of the things that we talk a lot about when we're talking about functions is the domain of a function. Now, the domain of a function is the set of y values, of x values. I don't know why I said y and wrote x. The domain is the set of x values. Any x value that we can plug into the equation belongs to the domain. Now, if we look at a linear equation in standard form or in y-intercept form, slope-intercept form, the domain of a linear function is always the set of all real numbers. The domain of a linear function is always the set of all real numbers. What does that mean? It means exactly that any value of x can be used as an input value for a linear equation. Now, this is true for all lines except vertical lines. So that's a pretty big except. Vertical lines are not functions. So for horizontal lines, diagonal lines, we have a function, and the domain, the x values, can be any real number. Vertical lines are not functions. But think about an equation like this. This is not a line. We have a fraction or a rational expression. We've worked with rational expressions. And what do we know about rational expressions? Well, we know that the denominator cannot equal 0. So that means that x minus 4 cannot equal 0. Well, that means that x cannot equal 4. So for my domain, this tells me that x can be every number, every real number, except 4. Because 4 makes the denominator equal 0. When the denominator is 0, this function is undefined. This is known as a domain restriction. Think about the number line. 0, 1, 2, 3, 4. X cannot equal 4, but it can equal every number down to negative infinity and every number up to positive infinity, not 4. We can use interval notation to describe the domain. Do you remember what we said about interval notation? We said that interval notation uses the endpoints. So I have one interval that goes from negative infinity to 4. It cannot equal negative infinity. It cannot equal 4. The other interval goes from 4 to infinity. We use a union symbol to say that the domain is both of these intervals. Notice I'm using an open circle here. Remember that that open circle tells me that X cannot equal 4. Let's try another one. The denominator cannot equal 0. Subtract 4, divide by 3. This is my domain restriction. X cannot equal negative 4/3. So if I think about that on a number line, X can equal every number down to negative infinity, every number up to positive infinity, but not negative 4/3. So my domain, using interval notation, I look at the endpoints. Negative infinity to negative 4/3, not equal to negative 4/3. 4/3 to infinity. Sorry, negative 4/3 to infinity with the union symbol. What about the next one? If I look at the denominator, there's no X there. In fact, this is a linear equation. Y equals mx plus b. There are no domain restrictions. X can be any real number. What does that mean for the domain? Well, that means it's all real numbers, all the way from negative infinity up to positive infinity. Finding domain takes some practice. Please go to Pearson, the homework assignments, find the domain questions, practice them.